to consider it. I don't think enough people do. Like, there's a lot of math involved, but so many people are scared of math and science careers because they're not straight A math students. But I know a lot of people who are in engineering, finance, accounting, and doing well in those careers is not like acing every math test. Okay, it's different. You go into engineering and you take a lot of math classes to get the degree, but then you're working in software, you're working with programs, and you're working in a team, and you're collaborating, and you have research. You know, it's much different than like a test environment. So when you're thinking about a math or science career, don't discount yourself because you're a C student. That's okay. You can still learn math and have a career in math. And meteorology is out there. I mean, yeah, and meteorology is out there, and there's a lot of math involved. So you see the person on TV, they probably have degrees, but there's so many people in the background that are doing the actual reading of climate, right? Doing the numbers and making the predictions, and it's a really important part of our world, predicting things like tornadoes. In the 1830s, am I in the right thing? I'm not. The equation for wind speed, W, in miles per hour, near the center of a tornado is W equals 93 times log base 10 D plus 65. D is the distance in miles that the tornado travels. You guys are being rude. I'm reading out loud. You're in a classroom. You're supposed to be quiet. Someone starts reading and stop talking. That's usually how we do things. So I'm going to write the equation, show you how to isolate log. W is wind speed, 93. We're going to do a lot of rewriting logs today. Times log base 10, D plus 65. So there's a lot of different math we do where you have to isolate first. So before we do anything, we're going to isolate the log. I'm going to isolate the logarithm. First thing I would do is subtract 60. It's asking us to put this in exponential form. And that's totally doable once we isolate log. Equation for wind speed if you know how far the tornado goes. What's our next step in getting the logarithm along? No. Good try though. Thanks for trying. Dividing. Let's get rid of this 93 in front. We're gonna divide both sides by 93. Yeah, that was probably your second guess for sure. I meant it. I don't know if people laughed. I meant it. So now we're ready to convert. Now that we've isolated the log, we can convert to exponent form. I think it's easiest to convert to exponent form when this whole bit is in parentheses. So with it in parentheses, you guys try put it in exponent form. Our next problem is about the fastest tornado ever in Oklahoma City. Do you guys think that the U.S. has the fastest tornadoes in the world? Or do we just like only focus on ourselves when it comes to tornadoes? Fastest in the world? I had to look into it because I was like, first off, this equation is in miles per hour and the rest of the world is kilometers. Second off, I just haven't heard much news about tornadoes in like Africa, China, Europe. You would think in the grasslands, right? Because we get them in Kansas, Oklahoma, South America, you would think anywhere that's like the same distance from the equator would have the similar climate and get tornadoes. There's actually only like 5 countries in the world that get tornadoes. I don't know. Well, some places get a lot of flooding. Some places get a lot of drought. We're actually very lucky climate-wise. It's one of the reasons we're so successful because we can grow so much food here. Right? So I would never call our climate or our natural resources unlucky. We're actually the luckiest here. Or maybe we just use it well. Look, our exponential form. So I'm going to do a big base 10. This is my exponent. This whole fraction equals the distance the tornado traveled. So number 21, in May of 1999, a tornado devastated Oklahoma City with the fastest wind speed ever recorded. So they didn't get the wind speed, but they did get maybe they did. But this just tells us the distance. The distance it went was 525 miles. That has to be like all of Oklahoma. That's really far. Estimate the wind speed at the center of the tornado. I looked it up. There may have been a faster one in 2013, but this one might still hold the record. Yeah, I actually have a video of this photo. So we're going to go back to the original problem. And this is going to be a calculator. It tells us the distance was 525. So this is a calculator. You guys calculate this. This is going to tell us the wind speed of this tornado. So I'll give you a moment. It takes a while to figure out how to do a log like this in a calculator, but if you have the class recommended calculator, it does it pretty easily. It'll do the whole thing at once. Yeah, round to the nearest mile. Speed? Gotta put 525 in first. So I hold that up. Close the parentheses around 525. Hey, let me help you out. So your calculator automatically puts a parenthesis here. You put it here. On the smaller calculator with the neon green button, you have to put this in first. And then hit the log button. Yes. I think you just won't close your parentheses right. Okay, times 93. That's fine. Times 93 and then add 65. What's that? No way. Where at? Oh, Georgia? Right now, today. Tell me right answer. Do 93 times log 525 parentheses 65 plus 65. Maybe it's over. Oh, okay. It's approximately 318 miles per hour. So you can the fastest tornado was logged at 318 miles per hour. So we don't get very many fast tornadoes here. We get hurricanes. What's the speed of a hurricane? Yeah, I think anything over 75 can be called a hurricane. So that's like a category 1. Yeah. The wind speed. Great question. How it's rotating. Yeah. Yeah. So this is faster than what's the Cat 5? You think? Yeah, I think that's faster than even a Category 5 hurricane. Tornadoes are way more fast. Yeah.
I still didn't get it. I got under. No, oh, you have that.
Something called a change
Wait, it's just that.
This at the end is going to tell us if our calculation was right. Please don't throw food in the class. We get ants. Can we put that away?
This tornado is probably going to have more like everything in its path. It is a massive tornado. It's coming to the city of Moore. It's now northwest 12, just west of Janeway. It's taking out a whole subdivision.
I love that show. Do they talk about the logarithm involved?
I have no idea. I think we should watch it.
Here's the Weather Channel. How many mathematicians are employed by the Weather Channel? A lot. Like everybody's there. So here's where hurricanes occur. I keep saying hurricanes. This is it for tornadoes, people. We're like one of the only people, us in Canada, we're like some of the only people who have to worry about tornadoes. What's wrong with the map? The entirety of Europe is actually left out of a lot of these. I don't know. Oh, moderate risk. So that's high risk. That's moderate risk. So we're the only people at high risk for tornadoes. What's the yellow dots? Oh, those are the 10 deadliest. So why was it so deadly here, even though it's just moderate? Maybe they didn't have a warning system. Maybe there was a very condensed population area. You know, or maybe it was a fluke. Maybe it was a fluke. This one here, it's like to the right of it. I think it might be Bangladesh. Where's Bangladesh? Because I read one of the worst tornadoes was in Bangladesh. Deadly why? Like the architecture probably. I mean, we shouldn't just assume anything, but. All right, we don't have any homework to check, so we're gonna go straight to Bangladesh. It's Bangladesh, not India. It's another little guy. It's a sovereign nation. All right, let's take some notes. All right, this comes from page 45. This is directly after the quiz. The quiz went through 7.4. This is chapter 7-5. We're going to work on rewriting logarithms today, understanding the properties of logarithms. So the first property is the product property. These properties are just exactly like the exponent properties, but inverse, because logs and exponential equations are inverse. So if you're adding the same log, rewrite it as one log by multiplying the arguments. It's called condensing. We are going to do numbers 1 and 2 here on your notes. So it's up to you how much you want to write of this. What are you saying? You're saying you want to run a mistake? So you want to call her right now? Hi, this is Mrs. Baldwin. Maybe Wallace was asking if you need to come to you about the FSA test. Yeah, you can go. All right, so example 1, you're adding. So when you multiply the same base of exponents, you add the exponent. So this is just the opposite. When we add these, since they're both log base 6, we can multiply the arguments, and that's called condensing. Condense the logarithm. So I'm going to write log base 6 And I'm going to do x times x minus 9 equals 2. So you're condensing it down to 1 log. Then I'll distribute. So Mark, what are your thoughts next? I'm right here.
Would you?
After this, you're going to write it in exponential form. Well, honestly, there's a lot of different ways these problems can present. So just make sure you're doing these as well. So exponential form, big base 6, logarithm solve for exponents. Big 2 here, I keep forgetting I should probably put this in parentheses, equals x squared minus 9x. Now, we no longer have a log equation at all. Now we're solving a quadratic equation. Or it could be cubic. Or it could be linear. You know, it could be anything, but it's not a logarithm anymore. So remember when you're solving quadratics, we need a 0. So I'm going to subtract 36 from both sides. So now I have 0 equals x squared minus 9x minus 36. Now we're solving a quadratic. What do we do? Oh, Alex, you have a question? From here to here. So remember that this is the base. In logarithms, solve for exponents. So this is your power. And this whole thing went here. Put the whole thing over there. So this factors. Anybody know these factors? What multiplies to negative 36 and adds to negative 9? Ava, you got it?
Negative 12.
Good job. X minus 12 and x plus 3. And we solve these. And that gives us our answers. X is 12 or x is negative 3. But one of these is extraneous. We got it right mathematically, but we're going to ditch this one. We're going to put a line through it. It doesn't count. It's extraneous. 12 is the only actual answer. You're not allowed to have a negative argument in a logarithm. So if I put negative 3 in the original right here, it's a rule breaker. This has to be positive. This would be a rule breaker too. So, do you guys want to do the next one? You want to just skip? There's more. I think we should skip. I'm going to go to the next example now. Skip that second one. There's 2 more properties I want to practice. So. The next 2 are the quotient property and the power property, and these are really just learning to rewrite logarithms. So if you have a problem with several logs, you can combine them to rewrite. Feel free to take a picture. Feel free to shorten it. This is right in your textbook, chapter 7-5. So Trey, how would you summarize the quotient property? What do you do if you're subtracting similar logs? We'll read it further. Look at the problem envelope. Ethan, what would you say if you're subtracting similar logs? How do you rewrite it? Divide your argument. Put the A over the B, or whatever's in the A spot over whatever's in the B spot. So subtraction leads to division. Just opposite of dividing exponents into subtraction. The power property, I've just been dying to do this whole time. With our drafting and everything. If there's a number being multiplied in here, like our tornado problem, you can put it as an exponent. It can become an exponent on the argument. So the coefficient can be rewritten as an exponent. And we'll typically do that property first. Yeah. So here in number 3, we're going to utilize the power property first. And I'm going to put this coefficient right here as an exponent on 6. So this is now 6 to the 3rd minus log base 4 of 8 equals log base 4 of x. And we know what 6 to the 3rd is, right? What's 6 to the 3rd? 6 times 6 times 6. 216. So I can deal with that. That's a 216 there. And so now here's where this new word condense comes into play. You see it in college algebra. Sometimes they say condense and expand logarithms. Condense and expand. This is an example of how to condense. So subtraction leads to fractions. So I'm going to do 1 log base 4. I put the 216 over the 8. So this will be the numerator, and this one is the denominator. And now I'm hoping that 216 does divide by 8. If it doesn't, we'll deal with it. But does it divide as well? What's it divided? 27. So this is actually log 4 of 27 equals log 4 of x. Yeah, where can I go from here? Hannah, what do you think? Brian's got it, right? Yeah, we can just cancel logs now. Same logs on both sides. Cancel logs, and 27 equals x. So all of the skills in our first 4 sections, well, really 7-3 and 7-4, put into play here with just this extra property in the beginning. Let's skip down here to this one. We'll do this one next. Last problem for class, and then you can remember your work. Alright, so I'll start with condensing. So we're going to do log base 2. I'll put the 4 up top and x plus 3 down below. And log base 2 of 8. We pull that chart. So again, this one goes in the numerator spot, and this one goes in the denominator spot. And now we can cancel log 4 over x plus 3 equals 8. This is a linear equation, so we have to think about how to get x alone. I'm gonna go about this. I think I can get this done in 2 more steps. I'm gonna multiply by x plus 3 on both sides. Cancel, cancel. And I have 4 equals 8x plus 24. Put the line in and get x alone. Now this is negative, so I have to check it. Is it going to be extraneous? Is this extraneous? Alexa, are you doing the problem? Do you think this will be extraneous? It's negative.
No, wait.
No or yes? I don't know. So the test is, can I plug it into the original problem and get a positive? So we'll have to check, and I'm going to check it here. So what is negative 28 divided by, is negative 20 divided by 8 less than 3? 20 divided by 8 is 2.5. So it's negative 2.5 plus 3. So that's a positive 0.5. So this checks out. That works. Lots of students are just saying that any negative answer is extraneous, and that's a mistake. You have to plug it in and do the math. Even though it's negative, it works. Very close. That's it. Some of your problems in your workbook might look different. Like these problems can present so differently. It has to be great for you. So some of your workbook problems might look different than this.